Welcome to Tech Blueprint, a window that lets you know the latest technology news in the world. Some media outlets predict that by 2034, the global microprocessor market will surge from $114.6 billion to $261.5 billion. In just 10 years, a semiconductor empire is being built. The Chinese market is booming, capturing $42.08 billion of the market share by 2024 and projected to surpass $100 billion by 2034. With this surge, even TSMC and Intel are likely to step aside, right? Asia-Pacific becomes global core. In 2024, the Asia-Pacific region captured 61.4% of the global microprocessor market, with revenue from this region alone soaring to $70.3 billion, essentially supporting the majority of the global market. China, in particular, has played an indispensable role, contributing $42.08 billion, roughly 60% of the Asia-Pacific market. This achievement is due not only to strong domestic manufacturing capabilities, but also to strong government support for the semiconductor industry. Take SMIC, for example. SMIC is a leading Chinese semiconductor company and has been steadily advancing its technology in recent years. In early September 2025, SMIC announced that the yield rate of its 14nm FinFET process had consistently exceeded 95%, and it had already begun supplying numerous domestic mobile phone brands and automotive electronics manufacturers. Who could have imagined this a few years ago? Back then, domestic mobile phone processors were entirely dependent on imports. Now, an increasing number of phone models are using SMIC-manufactured chips, which offer more reliable supply and significantly lower costs. For example, a mid-range phone released this year by a domestic mobile phone brand was equipped with a SMIC-manufactured chip. Shortly after its release, sales exceeded 1 million, with users reporting excellent battery life and performance. This isn't just a simple business success, it's an epic battle of technological breakthroughs. Technological upgrades never stop. The microprocessor industry is constantly moving towards ever more advanced technologies, and in this technological battle, the 2nm process has become the hottest topic. As soon as MediaTek announced the successful tape-out of its 2nm chip, projected to enter production by the end of 2026, TSMC immediately began building its 2nm production line. This process has dramatically increased mobile phone processor performance by approximately 18%, while also reducing power consumption by 6%. In addition to process upgrades, artificial intelligence is also quietly transforming the design and production of microprocessors. Chinese companies specializing in AI chips, which launched the Xiyuan 600 chip this year, are already being used in Alibaba cloud servers. Servers used to be incredibly slow when processing large amounts of data, but with the help of AI chips, data processing is much faster. Watching short videos and storing files in the cloud has seen a surge in speed, and it feels much more fluid than before. Currently, many domestically produced cars are being equipped with advanced driver assistance systems. The microprocessors in these systems process massive amounts of data from cameras and radar in real time. For example, if someone suddenly crosses the road, the brakes can react 0.3 seconds faster than before. This small difference can mean the difference between life and death in a car. Chips are everywhere. China has long achieved self-sufficiency in mature manufacturing processes. By the first half of 2025, the self-sufficiency rate for chips 28nm and above had climbed to 70%, and in niche areas like power management ICS, it had even surpassed 80%. However, China's ambitions extend beyond this. RISC-V is quietly rewriting the rules of the game in advanced architectures. Today's cars are becoming increasingly intelligent. In addition to automated driving assistance, the in-car infotainment system and battery management system also rely on microprocessors. Great Wall Motors' new energy vehicle, launched this year, is equipped with a domestically produced automotive-grade microprocessor. This chip manages navigation, music playback, and battery status monitoring all at once, making it both user-friendly and reliable. After more than 6 months on the market, there have been no reported issues due to chip issues. Many owners have commented on the incredibly fast response times when using voice control for navigation and air conditioning, unlike previous cars, where voice commands took several seconds to respond. Many domestic factories are upgrading their automation systems, with robots and sensors on production lines now powered by microprocessors. For example, at one power plant, product quality inspections used to rely on the human eye. Now, they've switched to intelligent, microprocessor-based inspection systems. These not only detect minor surface defects, but also transmit data to management in real time. This has increased production efficiency by 20%, and the product qualification rate has soared from 98% to 99.5%. Domestic substitution is steadily progressing. Although China's domestic microprocessor market is steadily growing, it also faces some challenges. Extreme ultraviolet lithography machines, required for high-end chip manufacturing, are a global challenge, with only a handful of manufacturers capable of producing them. Furthermore, external factors have disrupted the market, making them a significant investment. However, Chinese companies are not idle. Shanghai Microelectronics Equipment Company, Limited has been diligently developing domestic lithography machines. In August of this year, they announced that their 28 nanometers DUV lithography machine had passed multiple rounds of testing and was ready for mass production. While the 28 nanometers process isn't cutting edge, it's fully sufficient for applications in automotive electronics and industrial control. With domestically manufactured lithography machines, the future chip supply for these industries will be more reliable and secure. Besides ARM, a well-known chip architecture in China, RISC-V is also rapidly gaining ground. China's Core-Line technology, which launched its NA900 chip in the past 2 years, has successfully achieved the automotive industry's challenging ASILD safety certification, making it the world's first RISC-V architecture CPU IP to receive this certification. Microprocessors for Chinese-made cars now have the option of a domestically produced architecture, eliminating the need to rely solely on foreign licenses. This reduces costs and strengthens technological independence.